What if I told you that reality isn't what it seems? That particles can be in two places at once, or communicate instantly across the universe? This isn't science fiction. It's proven science, cemented not by theories alone, but by incredible, earth-shattering experiments. Welcome to Großdenken, my friends. Today, we're counting down the top 5 most mind-blowing physics experiments that actually forced us to rewrite the textbooks. Before we start, let me remind you to help this channel grow by subscribing. Let's dive in. At number 5, an experiment so foundational to quantum weirdness, the double slit experiment. In the early 1800s, Thomas Young shone light through 2 parallel slits onto a screen. Instead of 2 bright bars, he saw an interference pattern, a series of light and dark bands. This proved light behaved as a wave. But here's the modern mind blow. In the 20th century, we could fire single particles, electrons or even whole molecules, one at a time toward the slits. Common sense says each should go through one slit or the other and make 2 bars on the detector. But no, over time they built up an interference pattern. Each particle seemingly went through both slits and interfered with itself. The real kicker? When you place a detector to watch which slit the particle goes through, the interference pattern vanishes. You get 2 simple bands. The act of measurement changes the outcome. This experiment is the core proof of wave-particle duality and the observer effect, showing that at the quantum level, reality exists as a cloud of probabilities until it's measured. Number 4 is an experiment that found a stunning nothing and paved the way for Einstein. In 1887, physicists Albert Michelson and Edward Morley were trying to detect the luminiferous ether, a hypothetical medium through which light waves were thought to travel, like sound through air. Their tool was an interferometer, which split a light beam and sent it in 2 perpendicular directions, then recombined it. If Earth was moving through this ether, the speed of light along the 2 paths should differ slightly, creating an interference shift as the device was rotated. The result? Null, zero, nada. No difference in the speed of light was detected, no matter the direction or time of year. This failed experiment was one of the most important in history. It proved there is no ether and the speed of light is constant for all observers. This shocking result directly led Einstein to develop his theory of special relativity, revolutionizing our concepts of space and time. At number 3, an experiment that proves time travel is real, just not how you think. In 1971, physicists Joseph Haffel and Richard Keating took supremely accurate atomic clocks, put them on commercial jet planes, and flew them around the world. According to Einstein's relativity, time should pass slower for an object moving at high speed, time dilation, and faster for an object in a weaker gravitational field, like higher altitude. After flying eastward, westward, and comparing with clocks left on Earth, the results were clear and measurable. The traveling clocks had disagreed with the ground clocks by nanoseconds, exactly as relativity predicted. The flying clocks experienced less time. They literally traveled a tiny fraction into the future. This wasn't a theory anymore. It was a measured fact. Our GPS satellites have to correct for these same effects every single second, or they'd be useless. Number 2 tackles spooky action at a distance. Einstein hated the idea of quantum entanglement, where 2 linked particles instantly affect each other no matter the distance. He argued there must be hidden variables we don't see. In the 1960s, physicist John Bell proposed a way to test this. He devised a mathematical inequality. If hidden variables were real, experiments would stay below a certain limit. If quantum mechanics was correct, with true instantaneous connection, they'd violate this Bell's inequality. Starting in the 1970s and culminating in incredibly precise tests in the 2010s, like the Nobel-winning loophole-free experiments, researchers measured entangled particles. The results consistently and decisively violated Bell's inequality. There are no local hidden variables. Measuring one entangled particle immediately determines the state of its partner, even if they're light years apart. This spooky action is a verified fact of our universe, and it's the foundation of emerging technologies like quantum cryptography and computing. And our number one, most mind-blowing modern experiment, the direct detection of gravitational waves by LIGO in 2015. Einstein predicted that massive accelerating objects, like orbiting black holes, would create ripples in the very fabric of space-time itself, gravitational waves. But these waves are incredibly faint. By the time they reach Earth, they distort space by less than the width of a proton. To detect this, LIGO built two 4-kilometer-long L-shaped vacuum tunnels. A laser beam is split and sent down each arm, reflected back and recombined. A passing gravitational wave minutely changes one arm's length relative to the other, altering the laser interference pattern. On September 14, 2015, both detectors in Washington and Louisiana caught the same signal. The chirp of two black holes, 1.3 billion light-years away, spiraling together and merging. They observed the literal vibration of space-time. This wasn't just looking at the universe, it was listening to it for the first time, opening an entirely new window on cosmic events like neutron star collisions and the violent birth of black holes. From proving light is a wave and a particle, to discovering there's no ether, to confirming time dilation, quantum spookiness, and the ripples of space-time. These experiments didn't just discover new facts, they shattered our intuition and revealed a universe far more bizarre and wonderful than we ever imagined. What's the most mind-blowing result to you? Let me know in the comments below. If you want a deep dive into any one of these, hit the like button and tell me which one. And subscribe for more journeys to the edge of reality. Thanks for watching, and remember, the universe is under no obligation to make sense to you. But these experiments are our best tools to try. See you next time.